Yes, good morning all of you. Yesterday we seen about the synopsis of atomic structure. I think still hydrogen spectrum formula we discussed. So Lyman series, Balmer series, Paschen bracket, fund, everything we discussed. Now we are seeing further synopsis. Later we can go for competitive. C is nothing but quantum numbers. Quantum numbers are very important for Neet and JEE examination point of view. 90% question possibility from this one. See, we have 4 quantum numbers. Under this, a first quantum number is a principal quantum number. A quantum number. Sir, I will explain each and every point related to this one. The principal quantum number is invented by Niels Bohr, and it is denoted by letter small n, and n values are from where to where 1, 2, 3 and so on up to infinity. Based on n value we are giving the another names for the shells. Already yesterday we discussed n is equals to 1 means is a k shell or k orbit, and n is equals to 2 means is nothing but L shell, n is equals to 3 means is nothing but M shell. Sometimes he is representing names. N is equals to 4 means is nothing but N shell, like that another representations will be there. All of you clear? And according to or based on principal quantum number, what we can tell regarding chemicals? We can tell energy of orbit. Energy of orbit can we explain? We have formula for this one as 100%, and one more thing is nothing but angular momentum of electron in orbit. Also can we express is nothing but mvr is equals to nh by 2 pi. This n means is nothing but which one? Orbit number. I told already angular momentum of electron in second orbit. Angular momentum of electron in second orbit means n value has to be taken 2. 2h by 2 pi is nothing but h by pi is coming. This is one important bit. And from principal quantum number we can mainly explain the information related to shell or nothing but orbit. What is this one? So related to main orbit, what we can express is nothing but number of subcells. Can we explain from this one? Number of subcells in a shell is nothing but n, and number of orbitals in a shell or orbit is equals to n square, and number of electron in a orbit is nothing but 2n square. Number of subcells. Yes, every shell containing so many subcells. For example, atom is there, first shell, second shell, third shell. If n is equals to 1, how many subcells is there? Only 1s, that only n. Second shell containing 2 subcells, 2s and 2p. Third shell containing 3 subcells, 3s, 3p and 3d. Like that. And number of orbitals, you know very well, s orbital are of one type. Yes, I will write here s orbital is one type, p orbital is 3 types, d orbital is 5 types, and f orbital is 7 types. Okay, how many orbitals is coming? Only one orbital, n square, 1 square. Here 2 square, 4, 1 s orbital and 3 p orbitals. Here 9, 3 square, 1 plus 3 plus 5, nothing but 9. So like that. And how many electrons? Maximum capacity of s electron is nothing but 2n square, 2 electrons. P orbital 6 electrons, d orbital 10 electron maximum, f orbital 14 electron will be there. That information we are telling in the formula. Like regarding main shells, number of subcells is n, number of orbitals is n square, number of electrons is 2n square in the main shell. That information we are explaining from the principal quantum number. Now we are going for second quantum number is nothing but azimuthal quantum number. Azimuthal quantum number. This azimuthal quantum number is denoted by small l letter. So capital L means shell representation, small l means azimuthal quantum number. Who invented this quantum number is Sommerfeld. It is denoted by letter L, and L values from L values from where to where. Every point is very important. 0 to n minus 1. Okay, what is that one? I will explain to you. If suppose what will explaining by this quantum number? Shapes of orbitals. Okay, if L is equals to 0, always it is nothing but s orbital. Always s orbital is in which shape? Spherical in shape. Yes or no? And L is equals to 1 for p orbital is always dumbbell in shape. Dumbbell in shape. L is equals to 2 for all d orbitals. It's nothing but double dumbbell in shape. Double dumbbell shape. And L is equals to 3 is nothing but f orbital. It is in complex in shape or peculiar in shape, means we can't show on 2-dimensional. And mainly it will explaining about the L values for different orbitals we have to discuss. See carefully, is nothing but, for example, n is equals to 2, second orbit. What are the possible L values? 0 to n minus 1. 0, n minus 1 means 2 minus 1, 1. If L is equals to 0, s orbital, L is equals to 1, p orbital, second shell containing 2 subshells is nothing but s and p. Are you getting or no? Yes. Next we are going to discuss about the some other things is nothing but, for example, you have n is equals to 4. A possible L values from where to where? 0, 1, 2 and 3. S, p, d and f orbitals. All of you understanding or no? Yes, very important thing we are discussing all these. Mainly azimuthal quantum number focused on subshells. Principal quantum number focused on main shell or orbit, but this is explaining about the subshells. It means it tells about 2s, 2p, 3s, 3p, 3d, like that information is explained by the azimuthal quantum number. So number of orbitals in a subshell is equals to 2l plus 1. Okay, then number of electrons in a subshell is equals to every orbital accommodated with 2 electrons. 2 into 2l plus 1 we are getting. I will tell you one important thing. For example, you have 4p. So what is the L value for p orbital? 1. Nothing but 2 into 1 plus 1 is nothing but 3. So nothing but we are getting how many we are getting orbitals? 3 orbitals we are getting. So in 3 orbitals, what are the number of electrons? 2 into 2l plus 1 is nothing but 2 3s 6 electrons will be there. As the formula for number of orbitals in subshell 2l plus 1, number of electron in a subshell is nothing but 2 into 2l plus 1. And here we are discussing one more thing is nothing but orbital angular momentum. This is important bit. This is the angular momentum of electron in orbit. mvr is equals to nh by 2 pi. Orbital angular momentum is formula will be there, square root of L into L plus 1 into h by 2 pi. Orbital angular momentum. S orbital has angular momentum is how much? These all can be calculated. S is a very important bit. L is equals to 0 for which orbital? S orbital. For always S orbital angular momentum is 0. 0 into anything is nothing but 0 we are getting. Sometimes the same formula he is represented like h bar. H bar means h by 2 pi is nothing but square root of L into L plus 1 into h bar also he may gives, no problem. For example, you have 3D orbital. What is the angular momentum or orbital angular momentum? What is the L value for d orbital? 2. Yes, substitute here, square root of 2 into 2 plus 1, 3 into h by 2 pi is nothing but square root of 6 into h by 2 pi or nothing but square root of 6 into h bar. H bar also we can take. All of you understood or no? Yes. Next we are going to another quantum number is nothing but third one, a magnetic quantum number. Magnetic quantum number. This magnetic quantum number is denoted by M. Who invented this one is a very important thing. So majority students are doing mistake in this quantum number only in this question. Observe carefully. Magnetic quantum number is invented by Landé. So it is represented by M, and M having values or 2L plus 1 values. What is that one? I will explain. So these m values are from where to where? M values from minus L to plus L including 0. Minus L to plus L. Observe very carefully the things here. So what is this one? It is mainly explaining about the orientation of orbital. Orientation of orbital. What is the meaning of orientation? It is on axis or in between axis or what is the location and where it is distributing. These all things is explaining by the magnetic quantum number. Okay, now I will tell you one important thing. For example, you have 4p orbital is there. Okay, how many orientations having by p orbital? Okay, what is the L value for p orbital? 1. If L is equals to 1, m values are how many are there? M values are how many? 2 into 1 plus 1. Nothing but 3 values. Not equals to 3. 3 values. What are the 3 values? Minus L to plus L including 0. Minus L means minus 1, 0 plus 1. Yes, means the p orbital will having 3 different orientation. 3 different value means 3 different orientation. 3 different orientation means we are writing as px, py, and generally we are representing 0 for generally pz. For example, you have which one? 3d orbital is there. What are the m possible values? L is equals to how much? 2. Then we are getting m values are 2 into 2 plus 1, we are getting 5 values, not equals to 5. 5 values means from where to where? Minus L to plus L. Minus 2, minus 1, 0, plus 1, plus 2. Okay, for example, this is the dz square. The remaining we can give dxy, dyz, dzx, dx square minus y square. Did you got it? Yes, this is where you are doing mistake means m value is equals to 3. Wrong. M having 3 values. They are nothing but minus L to plus L including 0. Okay, now last quantum number is nothing but a spin quantum number. Spin quantum number. The spin quantum number is invented by two scientists, Uhlenbeck and Gaudsmit. Uhlenbeck and Gaudsmit. Okay, they are denoted by letter S. S having 2 values. S values are 2. One is plus of, another one is minus of. Plus of is represented by upward arrow mark. Minus of represented by downward arc. Sir, what is the meaning of plus of and minus of? Plus of means the around the nucleus electron revolving in clockwise rotation. Generally is not compulsory. Around the nucleus electron revolving in the opposite direction means anti-clockwise, denoted by minus of or downward arrow mark. The spin quantum number tells about spin of electron. Spin of electron. So here one important thing is there, spin angular momentum of electron is equals to formula square root of s into s plus 1 into h by 2 pi. Sir, what is the meaning of s? Spin of electrons. Spin of electrons. So what is the meaning of spin of electron? For example, I will tell you lithium is there, atomic number 3, configuration 1s2 2s1. How is the arrangement? Actually 1s has 2 electrons and 2s has 1 electron. Okay, this is plus of minus of cancelled. Because of unpaired electron only spin momentum is coming. How many are there? 1 unpaired electron. Each electron momentum is off. So is nothing but s value is equals to off. Not like that. For example, you have nitrogen, you have 7. So then do it configuration 1s2, 2s2 and 2p3. Here paired mutually cancelled, here paired mutually cancelled, but p orbitals are of 3 types, then 1 goes into each orbital. Okay, these 4 are mutually cancelled. How many unpaired electrons? Those only giving spin momentum. How many are there? 3 are there. Each one is off. Then 3 into off, 3 by 2. So S value is equals to 3 by 2. Substitute over there. Same thing here also. H by 2 pi is sometimes he may give as H bar. Whatever it is the same concept. All of you understood? These 4 quantum numbers are very important. We can get it. Just for you, I will tell you one question. For example, you can take sodium. I want 4 quantum numbers of the valence electron in the sodium. First of all, write down sodium atomic number 11, configuration 1s2, 2s2, 2p6 and 3s1. the last electron going into 3s orbital. That's why for that we have to write down the quantum numbers. So what is the n value for this one? N is equals to orbit number, nothing but third. And what is the L value ma? S orbital L value is 0. M is also becoming 0. And what about the spin? Maybe clockwise or anti-clockwise. Only one electron is there, clockwise is not compulsory. So single electron means he may give either plus of or minus of. Generally first electron means clockwise, second electron means anti-clockwise we are taking. Like that whatever bits he will give we can solve it. All of you understood? Yes. Now we will see some other things. See, carefully go through the concept. Yesterday also I given so many formulas related to hydrogen spectrum and as well as Bohr atomic model, radius, energy and everything I told. Just once you go through the formulas, just half an hour we can enjoy the things. Come to this thing. Now we are going to one more thing is nothing but nodes. Very important thing among nodes and this one. Okay, node means is a quite opposite to orbital. Orbital means what amount? Around the nucleus, the area where electron finding probability will be maximum is approximately equals to 95%. In any atom around the nucleus, imagine some particular three-dimensional region which different shapes. In that region, electron finding probability will be maximum, that is calling as orbital. Quite opposite means electron finding probability will be minimum is nothing but 0, that is calling as nodes. Okay, nodes are of two types. Listen the concept carefully. They are nothing but spherical nodes or radial node. It's a very important competitive bit. What is the meaning of spherical node or radial node? You have an atom. From the nucleus, we have to imagine one spherical region. We have to imagine in this spherical region, electron finding probability will be 0. Such regions or such spherical regions is calling as spherical nodes. We have formula, number of spherical nodes for any given orbital is equals to n minus L minus 1. For example, he given 3p orbital given. Okay, for 3p n is equals to 3, L is equals to 1. The number of spherical nodes 3 minus 1 is nothing but one spherical node is coming. That too where it is coming, you know, in between 2p and 3p. Means in between second orbit and third orbit. Why? Because p orbital will start at second orbit 2p and 3p. In between second and third we are getting a spherical node. If you can see, for example, 4s orbital. What is the n value for this one? 4. L is equals to 0. Okay, then we are getting n minus L. 4 minus 0 minus 1. We are getting which one? 3 spherical nodes we are getting. Where and where we are getting? Anybody? This is the first shell, second shell, third shell, fourth shell. Okay, first shell no chance. Between first and second we are getting 1, and between second and third 1, third and fourth 1 more. 3 spherical nodes we are getting. Are you getting? Yes. Now we are getting angular nodes or nodal planes. Angular nodes or nodal planes. Yes, means what is the meaning of nodal plane? Yes, you have an atom. By passing through the nucleus, we have to imagine one plane. In that plane, electron finding probability will be 0. That's calling as nodal plane. Formula, number of nodal planes or angular nodes is equals to L. Okay, sometimes he may ask total nodes is equals to spherical nodes plus angular nodes. Spherical nodes n minus L minus 1 plus L minus L cancel, n minus will be remaining. So these all are formulas you have to practice carefully. Okay, for example, you take any s orbital you can take, 3s orbital you take in. What is the L value for this one? 0. That's why for all s orbital always nodal planes is equals to 0. You can imagine a spherical region, however you imagine plane, there is no chance to get a plane without electron. Okay, like that if you can take 4p, any p orbital you can take L value is equals to 1 means one nodal plane is coming. What is that one? Px orbital is there, for this nodal plane is yz plane. Px orbital means what? Electron density on the x-axis, which plane is empty like that. And py orbital is there, what is the nodal plane? Xz plane. And pz orbital is there, what is the nodal plane? Xy plane. Like that we can take 5d orbital, any d orbital you can take. We are getting two nodal planes we are getting. In that dxy, dyz, dxz will be there. Very simple. What are the two nodal planes? Z missing, no. Xz is a one nodal plane, another one is yz. And xy and xz. And xy and yz. And we have one more special thing, dx square minus y square. Dx square minus y square means electron density on the axis. Then we are getting a plane by making angle 40 degrees between x and y. Like this one will be coming, like this one will be coming. Two nodal planes is coming in between xy axis by making 45 degrees angle. Okay, now dz square, no nodal plane. This is important point. Sir, d orbital has two nodal planes is meaningless. No nodal plane. Why no nodal plane? In case of dz square, electron density are dumbbell on z axis and also in xy plane. No plane is possible without electron, thus why nodal planes will be 0 for dz square. Are you getting or no? And we are going for some other important thing. Yes, the recently in January examination, Jan and February examination, he asked this question. In JEE examination is nothing but electron distribution curves. Electron distribution curves. So what are the electron radial distribution curves? Actually, these curves tells us in atom from the nucleus at what distance we have maximum possibility to find out the electrons. It's coming like a peaks. Okay, now electron distribution curves, we are telling about the radial function or D function. Sometimes he is asking this one also. D function is 4 pi r square into psi square into dr. So distance, radius from the nucleus or orbit, and this is the psi square is the square of the wave function, always will be positive values. Okay, now if we can see for example 4s orbital. If you take here D function, electron finding probability function on y-axis, the distance from the nucleus on x-axis. For 4s orbital, how many peaks you may get? It means 1, 2, 3 and 4 you are getting. So how many maximas you are getting means is nothing but like this we are getting. This is for 1s orbital, this is for 2s orbital, this is for 3s orbital, our orbital is 4s orbital. Okay, here formula will be there. In this distribution curves, it means electron, s orbital electron can be find out in the first orbit as well as second orbit, third orbit, but maximum 4s means fourth orbit distance. This is the radius of the first orbit, this is the radius of the second orbit, this is the radius of the third orbit, this is the radius of the fourth orbit. Yes, in any orbital formula, number of maximas is equals to n minus L. Number of maximas is equals to n minus L we are getting, and number of minimas is equals to n minus L minus 1 we are getting. So means actually we are getting for this 4s orbital, no, n minus L, 4 peaks we are getting. Yes or no? Why? Because n value 4, L value 0, 4 maximas you are getting. And minimas means minus 1. Minus 1 means how many we are getting? 1, 2, 3. They are calling as minimas. So these are calling as maximas. The minimas only nothing but the distance where electron finding probability will be 0. That is only nothing but spherical nodes. Number of minimas is nothing but spherical nodes. So in between first and second, second and third, third and fourth. For example, he may give for example 5D orbital. For 5D, how many maximas you are getting? Yes, number of maximas is equals to n minus L is there. That means 5 minus 2, nothing but 3 maximas you are getting. Number of minimas is equals to 2 we are getting. Anybody can guess where we are getting maximas? 3D as well as 4D and 5D, means at third orbit, fourth orbit and fifth orbit. If you can see the graph, you are getting like this. Yes, same question he asked. Okay, this is the distance of 3D, this is the 4D and 5D. How many minimas you are getting? 1 and 2. This is the third, fourth, fifth. In between third and 4, one spherical node, and in between 4 and 5, one spherical node is coming. It's a very important question. So number of maximas is equals to n minus L, number of minimas is equals to n minus n1 is nothing but spherical nodes will be coming. All of you understood? Yes. Now we are going to which one? Rules to fill the electrons. Rules to fill electrons in various atomic orbitals. We have 3 rules we have. First one we are discussing about Aufbau's principle. Aufbau principle. Aufbau principle means always electron should enter into least energy orbital. Sir, how can you tell this is the least? Guarantee question in the NEET examination as well as CET examination. So energy of orbital we can study based on its n plus L value. If n plus L value for the orbital will be low, energy of orbital will be less, then it will be a first electron enter into that least energy orbital. That is only Aufbau principle. If n plus L value is same, n plus L value is same, then energy of orbital is directly proportional to n value. N plus L value will be small, then energy will be small. For example, for the given orbital, n plus L value will be same, then energy comparison based on n value. I will tell you so many examples for you. For example, 4s and 3D is there, in which electron first enter. N plus L value 4 plus 0, 4. 3 plus L value for d orbital 2, 5. Which is the lesser n value? N plus L value 4. That's why less energy. Energy of 4s is more. That's why first electron enter into 4s, then electron enter into 3D. No, for example, you have 4s and 3p. Okay, 4 plus 0 we are getting 4. 3 plus 1 we are getting 4. The same n plus n value, then both are having same energy. No, why? It is in third shell, it is in the fourth shell. As we go away from the nucleus, energy will be going on increasing. So then 3 and 4 more n value, more energy. That's why we are taking 4s is a more energy than 3p orbital. Okay, he may give few orbitals. For example, 3d, 5p and 4s will be there. Keep them in the energy increasing or decreasing order. 3 plus 2, 5. 5 plus 1, 6. 4 plus 0, 4. Yes, all are different n plus n value. Then energy is directly proportional to n plus n value. Least n plus n value, least energy. That's why 4s, after that 3d, after that 5p. This is the energy order of various atomic orbital. First electron enter into this one, next like that. That's only calling as Aufbau principle. Okay, but here one thing is there. In case of hydrogen atom and like species means the species which are containing one electron. Important bit, so many times he asked. In case of hydrogen like species means containing single electron, what happening in the second shell, the 2s and 2p are having same energy. Why? Because only one electron that is in first shell. That's why what happening, 1s will be there, and after that 2s and 2p both are having same energy in single electronic species. Actually 2p is more energy than 2s orbital multi-electronic species, but in hydrogen atom this is also having same energy. Why? Because only one electron is there, so no much repulsion between s and p orbital, both are having same attraction with this particle. That's why we are getting almost same things. We are getting same energy, we are getting, that is nothing but hydrogen like species.